And this is the other half of my experiment. This is a positive power point. This is a negative power point. This is a capacitor with some neon bulbs across it. If they ever get a high voltage, they'll bleed it off. Lots of coils and contraptions hooked up. Driven mostly by this transistor joule thief thing. Yeah, I don't know what that is. I'll focus right there. Oh, well. So I have this powered up with a 9-volt battery right now and an oscilloscope across some various places. So connect my power. I have pulse. I have many ripples in it. Oops. I accidentally reset this. This should be DC. So that's I don't know, volts. This is another. This is across this bringing RC coil. So this is my wave now. I set my trigger to 2 and falling or something. Okay, so and I don't know. That bottoms out. That's not really very deep. And that's the gate. So that's really when it's turning off. And I can change this jumper here. And it changes nothing at all. Except now it's just a huge wave. It's not really huge. So I get that sawtooth, and I can connect it and move it back a point. And then I get interference on my other wave. And I can move back another step. Another step. That looks kind of nice. I don't know, that's higher frequency. It's got more bounces and ripples in it. But, yeah, so that's changing the capacitance on that L2CX constant that's on all these coil. And how it affects the ringing of that. And I have another point here. Yeah, I could connect that bridge rectifier. These are on opposite sides of it, and if I short them, I get nasty stuff like that. It doesn't work. And then if I put a capacitor, a really tiny, and then a really tiny capacitor, this changes that ripple to that feedback. Disconnected, connected. So that's set 2 farads, 2 nanofarad, and so that's the excess resonance across that. Really, most of that should be going into the capacitor, but once the capacitor has a charge, there is a reflection from the capacitor that would be there across the secondary of this.